So now finally your midterm is over, right? And your end term will be in April end, correct? So for that you have to study like what is left for BET especially. We are left with a three-phase AC circuit, that is star, delta. Okay, this is the easiest, I must say, and this is the scoring unit or chapter from complete BET. Okay, another subtopic is related to the electrical power system, that is electrical machine, motors, and everything. And generally, what I saw in Manipal, they people don't teach you this because it's almost end, it comes up to end only, and your teacher will say ki do it by your own, like only you are left with the two unit, one is three phase AC circuit analysis, another one is electrical power system component, that is for BET only. FE is different. FE, for FE student means computer science background students, they have to study one more unit. So this is maximum of the theory. Okay, that's why teacher says that do it by your own. Clear? One thing. Second thing, it is very easy. So let's start with the three phase AC only. Wait. Yes. So I'll tell you this. Yeah, let's start. So basically supply is divided basically into two categories. One of the supply is the single phase supply and another supply is the three phase supply. Single phase supply means we are having single wire having current, and three phase supply means we'll have three wire and three wire current. So basically what are the color notation according to India? One three wire means one wire is of red color, another wire is of yellow color, another wire is of blue color, that is denoted by RYB. Okay, like as you know, at our home we'll have a socket like kind of this only, right? And have you ever placed a tester on this socket? Anyone? If you put a tester over in this socket, you will see that a light will blink on that tester. Okay, so that shows there is a current over there. So that is for the single phase. Basically what I want to say, whatever the home appliances we are using, they all are the single phase supply. ठीक है, जितने भी हम घरों में supply use करते हैं, that is the single phase supply only. Three phase supply means three wires. Generally we'll get it in factories or maybe your mall or maybe your hostel, because it needs a large amount of current, and your college. Okay, so now see, if I'll provide you three wires, one is of red color, another one is of yellow color, and another one is of blue color, and I'll tell you कि you have to connect these three wires with each other. Tell me the possible ways of connection. Like we can connect it like this कि red को yellow से and yellow को blue से, right? And then back to this. So see, we'll connect red and then yellow and then blue like this, or we can connect red, yellow and blue like this. Is there any another possible way also of connection? Yes or no? No, now. So it looks like a star, that's why it is known as star connection. It's look like a delta, that's why it is known as delta connection. Got it? So one by one we'll study about the star connection and delta connection. So let's start with the star connection. Star connection is like this. These are basically the windings, okay, with the three wires. What are those three wires? Can you tell me? that is red, yellow and blue. R for red, Y for yellow and B for blue. So this is basically R, Y, B. If ध्यान से समझना, if we'll have a plain wire, then that plain wire is technically known as line. Okay. And if we'll have the wires of winding, then technically it is denoted by the phase. Okay, clear? Now tell me, if there is a plain wire, that is denoted by line, and if there is a winding, then that is denoted by phase. ठीक है? Now suppose R, Y, B is there. I am marking the current. Current across R would be IR, right? Current across Y would be IY. Current across B would be IB. Okay. This three phase connection is so important for you. कि if you'll do question of three phase connection, ठीक है? Three phase connection का तुमने question, दो question they'll give it to you, two questions they'll give it to you, and two questions are correct and they you did it correct, so no one can fail you in BT. ठीक है? ये इतना strong होता है because 10 marks will cover from this three phase connection. So 10 marks अगर तुम्हारे आ गए तो बाकी तो ऊपर नीचे थोड़ा बहुत तो आ ही जाएंगे, है ना? So that's why I'm saying कि if you know three phase connection तो तुम्हारी बैक नहीं आएगी एटलीस्ट BT में. ठीक है? Okay, anyways, IR, IY, IB. So now tell me this IR, IY and IB. These are the line current or the phase current? बताओ मुझे. These are flowing across the plain wire. So plain wire means it's a line. So it is line current, and line current is denoted by IL, right? So we'll have a neutral connected in between which connect all the three wires. Now we'll mark the current across neutral and R. So that would be INR, INR. The current between N and Y would be how much? INY. Current between N and B would be how much? INB. So INR would be equal to INY, would be equal to INB, would be equal to I phase, right? That is equals to I phase because it is moving across the winding. Correct? Now tell me, just look at the diagram. Is IR equals to INR? Yes or no? Because this is in series, and as you can see that current is not deviating somewhere, so that means current is moving and that is the same current. So what we can conclude that IR is the line current and INR is the phase current. So what we can conclude from here, that in this case of star connection, line current is always equals to the phase current. Yes or no? So basically there are two types of load we'll have. One is the balanced load. In the balanced load means all impedance is same. Like if it is 2 ohm, this is also 2 ohm and this is also 2 ohm. This is the case of balanced load. So in the balanced load, current is also equal. If impedance and voltage is equal, then current is also equal now. There is another case of unbalanced that we'll discuss later on. First of all, tell me, is there any doubt up to here? Now similarly we'll mark the voltage as we have done for the current. Try to mark voltage by your own. This is R, this is Y, this is B. So let's mark voltage. Voltage between R and Y would be VRY. Voltage between VY and B would be VYB, and voltage between R and B would be VRB. Yes or no? So now tell me, these voltages are the line voltage or the phase voltage according to you? These are the line because we have marked it across the line. So VL would be equal to VRY is equal to VYB is equal to VRB, right? Now we'll mark the similar kind of phase voltage. It would be VNR, VNY, and sorry, it is connected between N and B, so it would be VNB, it would be VNY. So VPH would be equal to VNR is equal to VNY is equals to VNB. Okay. Now tell me, is VRY equals to VNR? Yes or no? Just look at it and tell me. So they are not equal, right? So it means will have some relationship between the line voltage and phase voltage. In Manipal, derivation will never come. So I'm telling you that the direct relationship that line voltage must be equal to the √3 times voltage of phase. So you need to remember this for the star connection, that line voltage must be equal to √3 times of phase voltage. Okay. Like what we have done studied up to here, that in case of star connection, line current must be equal to the phase current and line voltage must be equal to the √3 times of phase voltage. Now tell me, any doubt up to here? Now let's go with the delta connection. In case of delta connection, as you know, delta looks like this. This is R, this is Y, this is B, right? So let us consider this point would be 1, this point would be 2, and this point would be 3. So now I'm marking the voltage. Voltage between R and Y would be VRY. Voltage between VY and B would be VYB. Voltage between R and B would be VRB. So now tell me, these are the line voltage or the phase voltage? These are the line voltage. Now we'll mark across the phase. Voltage between 1 and 2 would be V12. Voltage between 2 and 3 would be V23. Voltage between 1 and 3 would be V13. So what we can do, that VPH is equal to V12 is equal to V23 is equal to V13. Okay. Now I am asking you one question, that is VRY would be equal to V12? Yes or no? According to you. So you can consider it as a parallel also. In parallel, voltage is same, so it is same. So what we can conclude, that VRY is the line voltage and V12 is the phase voltage. That VL must be equal to the VPH, right? Now after that, similarly, we'll draw the diagram again for the delta, and now we'll mark the current. So it would be again R, Y, B. Current would be over here is IR, IY, and IB. This is 1, 2, and 3. So what is the line current? IL would be equal to IR is equals to IY is equals to IB. And phase current would be IPH is equal to I12 is equal to I23 is equals to I13. So now tell me, in this case, like suppose if I'll mark the current, this one would be I12, this one would be I13, and this one would be I23. So now tell me, I12 must be equal to IR? Yes or no, according to you? So they are not equal. Again, there is a relationship that IL is equals to √3 IPH. Derivation, you don't need to go into detail. That's why I'm not telling you the derivation, because in Manipal they'll never ask. So this is the case of star connection and delta connection. In the delta connection, voltage is equals, basically how will you remember? this thing that in the star connection current is equal. Okay, if current is equal then voltage is different, and if in the star current is equal to delta में voltage equal होगा, vice versa, and current would be different, that would be IL is equals to √3 IPH. Okay, I told you all this thing because you won't be able to solve numerical without knowing this thing. Clear? Now in these kinds of question we'll have formula which we'll use, that is VPH is equals to IPH into ZPH, that is according to Ohm's law, and we need to calculate active power, reactive power and apparent power. Remember you have done the in the AC circuit the formula for the active, reactive and apparent. Can you tell me the formula for the active? So if we want to calculate power in terms of line, so it would be √3 VL IL cos phi. Reactive power would be √3 VL IL sin phi, and apparent power would be √3 VL IL. Okay, and if we want to calculate power in terms of phase, 3 VPH IPH cos phi, 3 VPH IPH sin phi, or 3 VPH IPH. Unit for active power is same like watts, VAR, volt ampere reactive and VA. So basically you need to learn this formula. If you calculate it by line and or phase, answer would be same for both the cases. Okay. Okay. See in this case what they said, a 3-phase 400 volt. Here line voltage is how much? 400 volt. Now you'll say ki ma'am how do you know it's line voltage? So they'll never mention which voltage it is, and if they didn't mention anything you have to take that voltage as automatically the line voltage only. Okay, so VL is equals to 400 volt. Okay, 50 hertz. 50 hertz is the frequency. Write down frequency is equals to 50 hertz. AC supply is given to 3-phase delta connected. Delta means we'll have the voltage equal, that is VL is equals to VPH and IL is equals to √3 IPH. Okay. Then each phase of the load consists of 10 ohm, R is equals to 10 ohm, and inductance L is equals to 20 millihenry, right? Now they are asking line current and phase current. Okay? Now as you know, like these are the given condition and this is the thing which we need to calculate. In these kinds of cases we'll always use Ohm's law. What is Ohm's law? That is VPH is equals to IPH into ZPH. Okay? Write down one more thing कि हमेशा ये Z is always in phase, right? Z कभी भी line में नहीं होगा. तो we'll never use this formula VL is equals to IL into ZL. लिखो और उसको काट दो. क्यों? क्योंकि 90% of the student use this formula. All the things you will get it in line. तो ये easy convenient लगता है, students will use this. No, but this is the actual formula. ठीक है? So for that we need to get ZPH, right? Because we don't have ZPH. As you know, ZPH is how much? R plus JXL, right? R is given how much? 10 ohm. J is as it is. XL is how much? 2 pi FL, right? XL is 2 pi FL. So it would be how much? 10 plus J, 2 pi F is how much? 50 and L is how much? 20 millihenry. So 20 into 10 raised power minus 3. तो इसको solve करो and tell me क्या value आ रही है. Okay, so ZPH is how much? 10 plus J 6.28. Z is equal to 10 plus J 6.28. So now we'll have ZPH also 10 plus J 6.28. We need to convert it into polar form because for multiplication or division we need polar form, right? Remember now how will we do in polar form or rectangular form? So we'll have one formula that VPH is equals to IPH into ZPH. VPH is how much? That we don't know. VL is 400. VPH is how much? In delta connection it is same, so it is also 400. IPH we need to calculate, and ZPH is how much? 10 plus J 6.28. So you need to convert it into polar form, then you will get some value. Okay, now you can see 400, there is nothing, angle is given, so we can take 400 angle 0. After that, phase current and line current. This is phase current, and then divided multiplied by √3, you will get line current, right? Then they are asking power factor. As you know, what is power factor? Cos phi, and phi is the angle of impedance, right? So whatever the angle of impedance you are getting, that is phi only. You can substitute the value. You already calculated the angle of impedance now by converting this Z as into polar form, 10 plus J 6.28, right? After converting, what you are getting phi, that is power factor, you will get it as 0.8467, right? 8.8467. Total power consumed means you need to calculate active power, that you know, √3 VL IL cos phi. √3, you know, VL, you know, that is how much is the VL? 400. Correct? In the power you only need to take the magnitude, never take angle in the power. Okay, current also you are getting, that is 33.87, and cos phi also you are getting 0.84. You can multiply it, then you will get